Welcome to This Explainer. Today, we're diving into a massive, fundamental shift in exactly how we build our world. For decades, engineering was pretty much just about the rigorous math required to, say, keep a suspension bridge from collapsing into a river. But things have changed. Modern engineering is no longer just about building things. It's fundamentally about sustaining the planet. So that brings us to a really big question. What does it actually take to build the future? I want you to think way beyond the mechanics of concrete, steel, or even code. The builders of tomorrow actually need a completely different operating system, a vastly expanded skill set, if they're going to navigate the incredibly complex challenges of our time. Okay, let's dive right into our roadmap for today. We'll be looking at defining the modern engineer, the core knowledge and competencies they need, the 17 global goals, engineering for sustainability, and finally, the ethical engineer. Starting off with Section 1, defining the modern engineer beyond math and science. We are right in the middle of a major paradigm shift, but to really grasp it, we need to cut through the jargon and define two absolutely crucial acronyms. Because, well, what's engineering without a few acronyms, right? First up, POs, or Program Outcomes. These are the complex problem-solving abilities you actually have to consistently demonstrate out in the real world. Second, WKs, or Knowledge Profiles. These are the deep theoretical and practical frameworks that support those abilities. To put it simply, POs are what you can achieve, and WKs are what you need to know to achieve it. Just think about the stark contrast between traditional and modern design. In the past, traditional design focused heavily on the mechanics, basically, will the water pump work? But consider PO3, which sets the standard for modern design. It actually mandates creative solutions that factor in public health, whole life cost, net zero carbon, and even local culture. The responsibility isn't just making sure the pump functions anymore, it's making absolutely sure that facility protects the ecosystem around it. It's a whole new ballgame. Moving on to Section 2, Core Knowledge and Competencies, the toolkit of the modern builder. So, how does this actually work in practice? Well, foundational knowledge maps directly onto those big problem-solving outcomes. For instance, PO1 and PO2, which are engineering knowledge and problem analysis, are directly powered by knowledge profiles 1 through 4. Practically speaking, this means taking the natural sciences, combining them with advanced math and computing data, and applying the whole shebang to solve problems sustainably. The hard sciences are now permanently tethered to sustainable problem solving. But, the modern toolkit goes way further than just that. Program Outcomes 4 and 5 demand some serious critical thinking, deep literature research, and the ability to select modern IT tools while, crucially, recognizing their limitations. And perhaps the most important one of all, Program Outcome 11, lifelong learning. Let's be real. In a world where technology is shifting practically overnight, an engineer's absolute most valuable tool is adaptability. All right, Section 3, the 17 Global Goals, the UN's 2030 Agenda. Now, you might be wondering, what exactly is this massive new toolkit actually being used to solve? Well, consider the sheer scale of ambition we're dealing with here. We're talking about the 17 Integrated Sustainable Development Goals, which were adopted by every single UN member state back in 2015. This isn't just some nice-sounding political poster. It's a literal, universal call to action. From eliminating poverty to ensuring clean water, these are without a doubt the greatest challenges facing humanity today. And it's absolutely vital to recognize that the 2030 Agenda balances 3 deeply interconnected dimensions: the economic, the social, and the environmental. These aren't just your standard green initiatives. They are a really delicate balance of people, planet, and prosperity. You simply cannot build sustainable cities without simultaneously addressing both economic growth and environmental impact. They go hand in hand. Which brings us to Section 4. Engineering for Sustainability, the intersection of action and impact. This is where the theory actually translates into survival. We're talking about specific UN targets that are almost entirely driven by engineering, increasing the share of renewable energy for Target 7.2, developing reliable infrastructure, expanding sustainable transport, achieving efficient resource use, and strengthening climate resilience. This isn't a wish list, folks. It's the ultimate checklist for the modern builder, because without deliberate, focused engineering, achieving these targets is basically physically impossible. So the crucial point here is how explicitly these engineering knowledge profiles link right back to the UN goals. Take Knowledge Profile 5, for example. It literally dictates deep knowledge of efficient resource use, whole life cost, and net zero carbon. See how perfectly that aligns? Efficient resource use directly drives responsible consumption. Net zero carbon is what enables climate action and clean energy. The engineering knowledge profile is quite literally the skeleton key to unlocking these global goals. And all of this connection is formally baked right into Program Outcome 6, which is appropriately titled The Engineer and the World. Engineers are now strictly required to analyze and evaluate societal and environmental aspects while solving complex problems. By tying together their knowledge of natural sciences and sustainable resources, professionals are inextricably bound to the real-world impact of their work. The math they do and the society it impacts are now one and the same. And finally, Section 5, the ethical engineer, responsibility to the world. At the end of the day, all of this requires a deeply human element to execute responsibly. I want to share a really powerful mandate straight from Program Outcome 7. Apply ethical principles and commit to professional ethics, human values, diversity and inclusion, adhere to national and international laws. It's a stark reminder, right? All the predictive data modeling in the world absolutely must be governed by a strict moral compass. Technical competence without human character is just a massive global liability. And this ethical mandate is brilliantly backed up by Knowledge Profile 9, which acts as the framework for inclusion. It goes way beyond just knowing professional norms to demand a genuine, active awareness of the need for diversity, expressly calling out ethnicity, gender, age, and physical ability. The logic is simple. If we're going to build infrastructure for humanity, we desperately need a workforce that truly respects and reflects all of humanity. So we've covered the massive paradigm shift from basic math to real societal impact, the sheer scale of the UN's global goals, and those vital ethical foundations required to bridge them together. So I'll leave you with this final provocative thought. If modern engineering is no longer just about building things, but about actively sustaining the planet, what exactly are you building today? Whether you're designing a power grid, managing a team, or you're just an informed citizen, the blueprint for tomorrow is in our hands. Thanks so much for joining me on this explainer, and let's go out there and keep building a better world.